Today we're going to be repairing an iPhone 12. The issue was that the original screen touch functionality didn't work, but the touch functionality worked with the third-party screen. This phone has obviously been worked on prior. The touch function worked fine when it's tested with an aftermarket display. So let's go ahead and disconnect this display and connect up the original to see what differences there are. After reinstalling the original screen and powering it on for testing, the touch functionality is completely unresponsive. And there are a variety of things that can cause this type of issue. The trick is going to be troubleshooting and figuring out what that issue might be. As you can see, we have no touch. Unresponsive entirely. It might have something to do with the fact that this has been worked on before. Maybe they're missing something crucial, or maybe there's been some other type of damage that we just can't tell right now. Disconnect the battery and disconnect the display, and you can definitely see that the motherboard has been worked on, as the shield is missing here in the middle of it. Let's carefully remove all of the screws and take out the motherboard. This motherboard obviously has a 5G antenna, and if you wanted to remove the battery and remove all of the bracket and screws, you can do that to remove it, or you can quickly desolder it if you're comfortable soldering a new one back on in the end. Looking at the motherboard, it is more than evident that the previous repair tech had been working on the touch power supply portion of the motherboard. A wire had been soldered in this area, and a 4-pin chip had been removed. JC Drawing will also be able to provide you with the data points on this in the schematic and board view side of things. We use the CXW schematic to locate the corresponding position. In the schematic, we can see that the previous technician removed a 5.5 switch transistor, the U8910. They forcibly applied a 5.5 input to a capacitor on the output side of that rail. By doing this, you're basically stealing power from your neighbor. It'll work, so we really don't have to mess with this if it's actually supplying the right voltage, but it isn't optimal. Basically what they were doing is bypassing a rail and providing 5.5 volts from another rail to it. Let's not focus on that for now. Let's return to the touch connector itself to see if we can diagnose and figure this one out. Referring to the schematic, let's test the pins on the connector. Using our multimeter, we will be able to check the diode resistance on the motherboard to see if we get the required specifications of each pin. And as we go through it, everything so far is appearing to be normal, which makes me question what's going on here. We're going to be looking for any abnormalities, components that are reading short. After testing, we found that all of the resistance values look normal. Then we can focus on the power supply portion of the touch. Let's attach the original screen so we can test the voltage. And to simulate a power button press, we're going to be shorting out the power button pins. This way we can test whether or not the 5.5 volt rail is actually outputting the right value. We found that neither a 1 input or a 2 input are outputting the proper amount. We could then compare this to and see if there's any difference with the other screen. We can test again using an aftermarket screen to see if the touch still works and what the values are when we test it. Let's go ahead and get the aftermarket screen and connect up the connectors. go ahead and do the same thing, kind of prompting it to boot. At this point, we can see that both the front end input and the back end output were accurately testing 5.5 volts on the motherboard. This is why the third-party screen worked with normal touch functionality. Now this is turning out to be a very unique issue, where the touch seems to work properly with an aftermarket but not with the original. And looking around at the schematics, it's going to be a little bit difficult and tricky to isolate the issue. Because we're getting the proper values on the connector. But since the third-party screen is working, we can test it and we can kind of temporarily ignore this issue and see if we can determine what the issue might actually be between what is different between the aftermarket display and the original display. Given that the values that we read on each one of the pins are the same, we can determine that there's got to be something else here at play. And as we go over and double check each one of these pins against the schematics and with the multimeter, one thing that I'm assuming it's going to be, based off of what I can think is the only difference between an aftermarket screen and original screen when it comes to the connector itself, is the thickness of the actual connector. You may notice that when you connect them, they snap on differently. And when they snap on differently, that can cause issues. Just like aftermarket batteries can cause kind of a swelling in the connector that will cause an issue with the battery being used properly, the same can happen with these connectors. The aftermarket FPC connector is larger and it puts strain on the connector itself. As you can see, if we compare these side by side and overlay them, there is a difference in thickness. That is why no matter how we test, the values of the connector appear normal. After identifying the generated issue, we can basically assume that there's something going on with the connector, so we're going to replace that. We're going to use our hot air at just over 700 Fahrenheit with some low melt solder to quickly and easily remove it. And we're going to wick away the pads, prepping it for receiving some new solder. We'll clean it up with some isopropyl alcohol and a cotton swab. Add some high temperature thermal. We're going to add some high temperature solder paste to the connector, applying it really just to the pin area. I'm trying to avoid the ground pins for now. And we're going to get them as even as possible with solder. We'll clean up the flux and the remaining solder paste. Add some new flux, really make sure that we have equal amount of solder on each pad. Now we can take a new connector, add some flux to it, and we can pre-tin each individual pin. This will really help in the soldering process when we go to solder this down. Finally, let's apply a small amount of solder paste to the grounding pads so that they don't act as kind of a high point and keep the connector from sitting down properly. We'll gently warm up the connector. Wait for things to melt, and we can solder it in place by adding a little bit of extra flux to help things flow properly. Let's install the original screen to the motherboard and test it again. We'll connect up our power supply and prompt it to boot with the tweezers again, so that we can test and see if we have touch restored. There you can see the Apple logo, and if the touch works, that will have proven our theory that what it was the aftermarket screen had actually damaged the connector itself, preventing the pins from making contact, and only when the aftermarket screen was used would it be forced into that position where the pin would make contact and restore touch. This repair is basically complete. We'd still have to put it back together, but hopefully that helps you guys in the future.